Hello everyone, my name is Piyush Agare and I am here to present to you a poster on my research titled GatorByte, a low-cost real-time water resource monitoring platform. Before we dive into the details of this project, I want to talk a little about the problem that we are trying to solve. Clean and unpolluted water bodies are key indicators of healthy ecosystems. However, growing urbanization and agricultural activities are causing contamination of water with heavy metals, nutrients, and other pollutants. And as a result, many urban watersheds are impaired in the sense that they no longer are capable of serving as a safe habitat for aquatic and riparian life. Billions of dollars are spent every year in mitigation efforts, and such projects are taken without any concrete information. The traditional way of gaining intel involves a researcher visiting the site occasionally, collecting some water samples, bringing them back to the lab, and then analyzing the water to detect contaminants. Now, this method is very slow and it takes a couple of days to produce any actionable information. These methods also do not collect any spatial or geological geolocation data on the variation of water quality, and hence predicting or even estimating the location of source of pollution becomes really difficult. With this project, we are trying to get frequent and quick actionable information using Internet of Things in a cost-effective manner that will allow researchers and water resource managers to take actions before the contaminants do significant damage to the environment. In this slide, the primary goal of this project is to develop a low-cost, real-time, and open-source water quality monitoring buoy that can be dropped in a water body like a stream, lake, or a stormwater drain and can collect not just water quality metrics, but also the spatial information that will provide insights into how water quality varies with time as well as location. A web-based visualization tool will also be developed that will allow users to manage all their devices from a central location. Besides visualizing the data in real time using interactive maps and charts. The most notable features of GatorByte are as follows. Firstly, it is an open source project and will allow other researchers to modify the platform according to their needs. The GatorByte is also built using inexpensive and accessible components and a customizable 3D enclosure and printed circuit board. The hardware and software are modular and can be adapted to be used for different monitoring applications. The buoy is extremely compact with an outer diameter of 5.5 inches and can easily fit through stormwater drains. Here you can see the major components of the GatorByte. The platform contains a buoy and it can also be configured as a station without the GPS. It has cellular communication modules, onboard data logger for backup. The major sensors being used in GatorByte are pH, dissolved oxygen, temperature, and electroconductivity. Besides, we are also using GPS tracking to record the spatial information. The images here show the open source design for the circuit board and the 3D printed enclosure. You can also see the modular two-piece circuit design and the assembled 3D enclosure with the mounted 4G and GPS antenna. In figure number 2, you can see how the flow of data from the source, that is the buoy in a water body, and how it can help water resource managers make informed decisions. The next figure, that is the figure 3, shows a prototype web application that shows the data collected during a survey that we did in Gainesville a while back. Although the buoy used in this survey is a couple generations old, but the core components and the data format is the same. Now, this rudimentary web application visualizes the collected data using charts and maps for each water quality metric collected. With a couple of feature additions, you can see how one will be able to see the spatio-temporal variations in water quality over a geographical area and have better insights into where pollutants are being leaked into the water body. In the future, I plan to conduct more surveys for data collection. I have already made the software and hardware modular so the users will be able to add or remove sensors according to their needs without making significant changes to the hardware or the software. Moreover, a few more advanced features will be added to the web-based visualization tool. For instance, users will be able to send control commands to the devices with single click. I will also design a swarm of buoys that will be deployed almost at the same time over a water body and try to visualize the data on the web tool. And that's all from me. But before I finish, I'd like to thank my advisor, Dr. Eben Bean, for his help on this project. The project is funded by USEA and the Smart Path project, and I'm really thankful for that. Let me know if you have any questions, and thank you for your time.